So in this video, I'm going to talk about the types of connections in a three-phase system, as well as terminology we use in that connections. Okay, so far we know we have three windings. Okay, phase A, phase B, phase C, R1, 2, 3, or RYB. Okay, so that's A prime, B prime, C prime. Okay, those are the three windings. Now we can, how do we connect these three windings? We can connect them either star connection, that star connection is also called Y connection, or the second one is delta connection. Okay, here is a delta connection. Here is the delta connection. We'll talk about delta connection in a minute. So going back to the star connection. So here is the star, so that's my A. Please always follow this sequence when you label them. So that's my A. Okay, this is my A prime, B prime, C prime. Okay, so when I label them, I followed in clockwise direction. So A, B, C. Okay, now this is called phase, right? That one winding is called phase. That A prime, B prime, C prime also called neutral. Here I'm taking that as a neutral since I can ground that. Okay. The voltage between phase A and neutral is called VPH. So same thing with voltage between B and neutral. So this is called VBN. Okay, that's a phase voltage between B and neutral. And VCN, same thing between C and neutral, we call that as phase voltage. Okay, so we have three phase voltages, VAN, VBN, and VCN. We can simply call that as phase voltage. Okay, so VAN equal to VPH, voltage between phase and neutral, that's called phase value or phase voltage. Now the current passing through that winding is called phase current. So IPH is the phase current, so also called IA basically, but IPH is a good term, we'll use IPH. So that's IPH, phase current. So current flowing in the phase, that's called phase current. Now here this wire is called line. Okay, so that's line A, this is line B, and line C. We have three lines. Okay, so the current passing through the line is called line current. Why I'm drawing the current going out? Because I'm assuming this is a generator, so that's the reason I'm drawing the current is going out. If this is a motor where it collects the current, so I can say current is coming in. Okay, so that's how you can see which one is generator, which one is motor. If current is coming in, that's motor, because motor always takes the electrical energy, converts that into mechanical, whereas generator, it takes mechanical energy, converts that into electrical. So for generator, current is going out, for motor, current is coming in. Now the voltage between the lines VA and VB, the voltage between VAB is nothing but the line voltage. VAB is called line voltage. That's the voltage between two phases. Okay, now can I write VAB equal to VA minus VB? That's how we'll write, right? So I can say VA is nothing but, I can write VAN minus VBN. Why VAN and VBN? Because I know VAN equal to VA minus V neutral. What is V neutral? V neutral, which is grounded, so that value is 0. So VAN is simply VA, because VN equal to 0. So VAN or VA, I can write that as VAN. That's how I wrote VAN and VBN. Now in the previous video I showed you this. Say for example VAN equal to 120 at an angle of 0, then definitely VBN equal to 120 at an angle of minus 120, VCN equal to 120 at an angle of minus 240. Here we're talking about symmetrical system. Symmetrical means each phase is going to have the same value. So basically the number of windings on each coil, the number of each phase is going to be same. Okay, and the armature is rotating at the same constant speed for each winding, same speed for each winding. Okay, now so if you look at those numbers, so for example I have VAN equal to 120 at an angle of 0, VBN equal to 120 at an angle of minus 120. Okay, now if I add these two, VAB equal to VAN minus VBN, so 120 at an angle of 0 minus 120 at an angle of minus 120. If I convert this into, this is in polar format, convert this into rectangular format, so 120 at an angle of 120 plus A0 minus this value 120 at an angle of minus 120 is nothing but minus 60 minus J 103.92. So when I combine these two, I will end up with 120 minus of minus plus 60 minus of minus plus J 103.92. Okay, so basically 180 plus J 103.92. Now when I convert this into polar format, I will end up with square root 3 times 120 at an angle of positive 30 degrees. Okay, so basically this is 207 at an angle of 30 degrees. This is basically 207 at an angle of 30 degrees. Now, so when I compare the magnitudes, only magnitude, not the phase angle. So if I have VAN equal to 120, I'm just taking the magnitude. What is VAB? VAB must be square root 3 times 120. Same thing, if I have VBN equal to 120, then what is VBC? Square root 3 times 120. Same thing, VCN. VCN equal to 120, then VCA equal to root 3 times 120. So from this I can conclude that VL equal to root 3 VPH. Okay, that's really important, you need to remember. So in star connection, line voltage is always square root 3 times larger than the phase value. Now when it comes to the current, phase current, okay, before going to the current, I will talk about 30-degree angle in the same video when we come to the vector diagram. Now going to the phase current and line current. So if you look at the star connection, so here is my phase current IPH. Okay, I'm assuming this is a generator, so current is going out, and this is line current IL. Is this phase current and line current are the same? They are same because there is no, I mean, phase current or line current, it's not dividing anywhere. So in star connection, line current equal to phase current. Okay, so the two important points we learned here is in star connection, line current equal to phase current and line voltage equal to root 3 times phase voltage. Power is always in three-phase system, P equal to, I don't know why I forgot here, P equal to 3 times VPH IPH cos theta when it comes to three-phase system. So power in a three-phase system, P equal to 3 times VPH IPH cos theta, where theta is the angle between phase voltage and phase current. That's the basically power factor. Cos theta is nothing but power factor. Please look my other videos, especially AC power videos to know about power factor. Okay, now if I substitute V instead of VPH, I can substitute VL over square root 3 and IPH equal to IL. So P equal to root 3 VL IL cos theta. So probably I didn't forget this. Probably I'm talking about each phase. Here I'm talking about each phase. Power consumed or power supplied by each phase. P equal to VPH IPH cos theta. That's each phase. When it comes to three phases, P equal to 3 times VPH IPH cos theta or root 3 times VL IL cos theta. Now I'm going to draw the vector diagram. When I draw the vector diagram, always vector diagram is drawn for the phase voltages in star connection. When it comes to delta, it is a little bit different. So VA, okay, VB is coming after 120 degrees, so the angle between these two is 120. VB after 120, VC is coming, right? So the total angle between all these three values is 120, 120, 120. VA, VB, VC. So basically VA is nothing but VAN, VBN, VCN. Okay, because neutral value is 0. Now to get VAB, okay, I'm going to draw this in negative direction. So this is minus VB. VAN is nothing but, or sorry, VAB equal to VAN minus VBN. We just did that. Okay, so now that's my VBN, negative VBN. Now I need to add these two. This is my VAB. Now what is this angle? For sure this must be 60 degrees because it's exactly bisecting these two values. Okay, VAB is also bisecting these two values, so it must be 30 degrees. Okay, so when you look at VAN and VBN, VAB is in front of VAN, 30 degrees in front of VAN. So in engineering terminology, we call this as VAB is leading 30 degrees VAN. Okay, so in star connection, you can see in star connection, line voltage leads the phase voltage by 30 degrees. That's what this 30 degrees came from. Okay, so in star connection, line voltage leads the phase voltage 30 degrees, but the phase current and line currents are same, so there is no phase angle between them. So currents are same. I mean, we discussed IL and equal to IPH, so there is no. So based on the load, type of load, whether it is lagging load or leading load, so based on the load, either lagging or leading power factor. So say for example, lagging power factor, this is my IA. Based on phase angle, whatever that cos theta is, that's the theta phase angle between VPH and IPH. Okay, that's all. I'll stop here about the star connection. Next video I'll talk about the delta. Thank you.